Assalamualaikum warahmatullahi wabarakatuh. I am Muhammad SYAZWAN bin JASMAN. Today my group member and I will present about what is high voltage construction kit 4.0. First of all, I will introduce my group members, YONG and FAIRUZ bin SALLEH. We as a junior of testing engineer in FTKEE are required to recognize and trace clearly the important section of frequency converter. All the information in this presentation session we get from the manual book of High Voltage Construction Kit 4.0, and we also referring the lab session video from our instructor TS Dr. Zikri Abadi Baharudin. Thank you to our instructor. Objective for the lab session is to familiar and adapt the safety knowledge and standard operation procedure SOP for handling high voltage laboratory work. For teaching and learning process that use high voltage equipment, we must follow and know the safety rules and standard operation procedure SOP because the inject voltage is higher until 100 kV and we need to handle it carefully and to prevent from any accident that relate to high voltage. What is high voltage construction kit 4.0? The High Voltage Construction Kit 4.0 is a system of components for application in high voltage technology. The High Voltage Construction Kit 4.0 system can be divided into 3 sections. For the first section is the source, or we can know it as Kit FC cabinet and also known as frequency converter. The second component is the high voltage transformer, also known as single-phase AC voltage test transformers or external transformers. And the last component are the add-ons. High Voltage Construction Kit 4.0, which is the latest technology from Heavy Hypertronics from Switzerland. The Kit 4.0 is powered by a frequency converter, a device to convert grid frequency and voltage to another frequency and voltage. It is highly modular and is the ideal toolkit for conducting experiments in university and in research and development lab. A variety of experiments are possible with the generate AC, DC and impulse voltage. The left side figure show the front view and side view of frequency converter. The right side figure show the labeling of important connection port that have at frequency converter. Now I will explain about the trace power cable circuit. The figure shows the power cable circuit. For frequency converter system, it uses a main supply of 415 volt to power up the system. It starts from isolated switch which is 415 volt to the power block terminal inside the frequency converter. It uses 5 core cables which consists of chocolate cable, phase line 1, black cable, phase line 2, grey cable, phase line 3, and green-yellow cable, ground and PE, and blue cable for natural. From power terminal block, 2 lines will be distributed to the internal transformers and 1 line will distribute to current transformer CT. The internal transformers of frequency converter have capability to have a variable voltage from 0 volt until 400 volt. The current transformers are used to reduce the amount of current to very low current because it will use for controlling circuit system inside frequency converter. From internal transformers, 2-phase cable will go to the terminal output of frequency converter where it will supply the voltage from 0 volt until 400 volt and will connect to primary side of external transformers. The ground of the test bar must always be connected for safety purpose for those using this kit. That's all from me, and next time will be continued by my group member YONG. Thank you.
Okay, thank you SYAZWAN. My name is YONG. Before I present, I want to inform that the safety in the system high voltage are strongly highlighted. The lamp and alarm are one of the safety systems in the high voltage system. Then I will continue the presentation with the lamp and alarm circuit in the frequency converter. The terminal output lamp horn potential free of frequency converter is connected to the steel cage, lamp and horn. The cable used for the connection is black shielded cable. The lamp and the horn is installed at the top of the steel cage so that it can ensure all the students can notice whether the testing is running or not in the cage. There is a sensor between the steel door cage to ensure the safety of the student. If the steel door cage is closed properly, when the testing of high voltage started, the green lamp will be activated. If there has someone tried to open the steel door cage when the testing is running, the red lamp and the buzzer will be activated. The sound of the buzzer is like the ship horn. Do you heard the ship horn before? Let me show some video about the ship horn. Okay, from the video, we can see that the sound is loud and clear. Why the ship need to be horn so loud and clear? When they're navigating in the water, especially in the crowded condition, they can use the sound signal to announce their intention to the other ship. Same idea for this system. The horn is especially used to announce the one who wanted to enter the steel cage that the testing is running. Not only that, it also announced the one who in the control room that the cage is not closed properly and the safety of testing is not secure. The person in the control room should stop the system and check the condition of the door. Make sure the door is closed and no someone are trying to get into the cage. Then the testing can be started again. Next, I would like to present about the circuit of the interlock system in the frequency converter. The interlock system is a safety system in a high voltage lab to ensure the safety of students to perform a task. From the block diagram above, it connected from the terminal output of the frequency converter and connected to the control box in the control room. Then, the control box is connected to the latching sensor at the door of the control room. The sensor will do action whether to run the system or not. During the injection test, if the door is open, the latching sensor sends the signal to the control box and the red LED light will be blinking to alert that the failure in a system. The system cannot run until the door is closed properly, and the system must be reset again to perform a test. The function of the interlock is used to prevent a machine from harming students or damaging itself by preventing one element from changing state during the testing. In the circuit diagram above, the interlock is used to monitor the door to the high voltage part of the system, and to monitor if the ground rod is taken out from the high voltage. It can also be a door in a safety fence mounted around the high voltage part. That's all for my presentation. Now I will pass my presentation to my team member, FAIRUZ.
Thank you, Tio. Hi, Assalamualaikum. My name is FAIRUZ bin SALLEH. I would like to continue the presentation with the subtopic of emergency button circuit. The purpose of the emergency button is to stop the machinery quickly when there is a risk of injury or the workflow requires stopping. All machinery requires an emergency button unless it will not reduce the risk or the machine is hand operated. An emergency button must be highly visible in color and shape and must be easy to operate in emergency situation. In the terminal output of frequency converter, there is two terminal output emergency stop button. For the diagram above, one of the terminal output emergency stop of frequency converter is connected to the emergency button with the key in the control room. A white shielded cable are used for emergency connection to ensure safety for student and equipment. The emergency button is used to stop the testing in an emergency case. For an example, the system cannot be stopped when the laptop is hanged, so the key can switch to shut down all the system in the testing cage. Now, I would like to explain about the block diagram. In the block diagram, there are three parts. First, frequency converter. Second, emergency button with key. Third, system. Frequency converter will connect to the control box that is located in the control room. The connection between the control box and the frequency converter is used white shielded cable. The emergency button will connect to the control box and the system. When the emergency button is active, the system of the frequency converter cannot be run, and it isolated the connection power from the frequency converter. But when the emergency button is not active, the system will run as usual. Next, we will move to the circuit diagram that is shown in the slide. In the circuit diagram shown, the connection of emergency button with the power. The number of 02 and 01 is present as a contact. When the emergency button is not active, the contact will remain as a normally closed contact. But when the emergency button is activated, the contact will change from normally closed to the normally open contact. The system will be an open circuit. The function of this emergency button on this slide are to prevent any fault happen that can cause an injuries to the student and the equipment. Next, I would like to go to another subtopic that is grounding system. The grounding system is the protective system that carry unexpected electrical charge from the equipment to the ground. There are two types of grounding system. First, equipment grounding system. Second, earth grounding system. Equipment grounding system is connected to the transformer to protect the student against electrical shock from the stray electricity. Earth grounding system is the connection of the electrical system to the earth that has been terminated with the copper rod on the earthing chamber. From the block diagram above, the grounding is connected from the earthing chamber to the steel cage, frequency converter, and external transformer. The connection of the earthing is using the copper braided cable that terminates to the equipment body. This connection is to prevent the equipment that have conductive body from leakage voltage and prevent from harming the student or other equipment. The earthing chamber for the lab is separated from the earthing chamber building. This is to ensure that is no disturbance from surrounding machine enter the test field. In case of failure, the earth potential of the surrounding does not rise, cause damage to electrical equipment. For the high voltage grounding system, the value of the resistance must be below than 2 ohm. But for the building grounding system, it must be low than 10 ohm. The grounding system is to protect the equipment from leakage current or voltage and to protect the student from the electrical shock due to the body of equipment is high conductive. For the conclusion, the safety part is very important in this high voltage lab. Always remember the 5 basic safety rules for working with high voltage. First, second, prevent reconnection. Third, test for absence of harmful voltage. Fourth, ground and short circuit. 5, cover or close of nearby live path. Before the high voltage is connected, the responsible person for the test must verify that the test circuit is assembled correctly, the test object is connected correctly, all safety systems are operable, short circuit cables from the capacitor have to be removed, All persons have left the test area. Thank you. That's all for our presentation of this lab.